Okay, so before we continue more with the math of kinematics, we're going to start by visualizing one-dimensional motion. And one-dimensional motion just means that the object is moving only along a single axis, like forward or back. So here I've drawn a car next to a number line that we can use as our axis. And we need to also define which direction is positive and which direction is negative. So here to the right is positive and to the left is negative. So these quantities, the position, the velocity, and the acceleration, they're all vector quantities. That means that they have a direction and a magnitude. So the direction matters, basically. And we can draw the position as an arrow coming from the origin. And here I've drawn it as x because it's along the x direction. And then the velocity and the acceleration are usually drawn coming from the object itself. So here the velocity of this car is to the right, and the acceleration is to the left. And the length of these arrows are representing the magnitude. So that means a longer arrow would be a larger value for that quantity. So in this case, the position x is at +1 meters. And the velocity is at +2 meters per second because that arrow is about 2 meters per second long. And the acceleration here will be -1 meters per second squared because the acceleration is in the negative direction. So we can look at this 1 second later and see that the car has now moved along the direction that the velocity was in. And the velocity has changed by the acceleration. So the new position is now at +2.5 meters, and for now, don't worry about how I got that exact number. The velocity is at +1 meters per second because the acceleration has reduced that value, and the acceleration is still at -1 meter per second squared. So now I'm going to define another term for you. I'm going to define the speed, and the speed is simply equal to the magnitude of the velocity. In one dimension, you can think of it as the absolute value of the velocity. So the variable is s, and again, the units are meters per second, just like velocity, but the speed is equal to the absolute value. So that means if you had a negative velocity, the speed would still be a positive number. There are also a couple of things we can talk about when it comes to how the position is changing. So for example, if we look at two different moments in time, we can think of either how far the object has moved from its final position to its initial position, or we could also think about the total distance it has moved as it traveled. Well, basically, one of those is called the displacement. Displacement is simply the final position minus the initial position, and the variable for that is delta x. And the total distance traveled, the path matter. So if the car goes back and forth, the displacement might be very small because the final position would be almost the same as the initial position. But the total distance traveled would be larger because the car moved one direction and then it moved back. In this case, we can see that if the car moves forward a bit and then moves back, the displacement in this case would be about -3 meters because it started at +1 meters and it ended at -2 meters. So we have -2 minus 1 is equal to -3 meters. And the total distance traveled with the variable d would be equal to 2 plus 5 in this case because it traveled 2 meters forward and then 5 meters back. So we're adding up each individual part of this car's travel. So the total distance traveled then would be 7 meters. And we can use these terms to define some averages. For example, if we want to know the average velocity, which is given the variable v with a bar over it, that would be equal to the displacement over the amount of time it took. So delta x over delta t, where delta t is the total amount of time. And then the average speed, which is s with a bar over it, would be the total distance divided by the amount of time it took.